that's suited for both general game design as well as general game playing. So the aim is to produce a system that will help humans design games, but also allow to do the process automatically. And the focus here is on traditional games rather than video games. So for general game playing, the main priorities are probably correctness, generality and efficiency. But for general game design, we have different needs. We want the language to be simple so that the designer can easily manipulate descriptions and try different variants. We want the language to be clear so that the rules are easy to understand. It should be general so it supports a range of mechanisms, extensible to allow new mechanisms, and it's good to be evolvable so that the process can be automated. Now, there are many game description languages, but none of them are ideal for traditional game design. So here's a few of the more well-known ones and the types of games they work for.
Wait, one moment.
So the question is, if we could produce a single language to cover all of these games, what would it look like? So I'll look at a few of these GDLs now. The Zillions rules file is from the Zillions of Games program from around 2000. It's very good for chess-like games, but gets less good the further you diverge from chess-like games. It's a high-level language. Here is tic-tac-toe as an example. And the user can define macros, which makes it reasonably extensible. It's very popular with hobbyists. It's probably the most successful commercial general game program. It's had almost no academic uptake, just a couple of papers use it. And it's pretty good for game design. These are some subjective estimates for the 5 properties I'm interested in. But it is really focused on chess-like games. Sorry?
You said these evaluations are subjective.
They're subjective, yeah. I haven't got numbers to back them up. Simplicity is basically how easy the language is to manipulate, to change and create variants. For generality, I consider the Board Game Geek database, and I just thought if you selected 100 games at random, how many of those could this language feasibly handle? And evolvability, how easy this language is to evolve. So the Stanford GDL is the one that most of you are probably most familiar with. This is the one used for the GGP competitions each year. It's very popular with academics, but it's had almost no consumer uptake. And it's very good as a platform for GGP research, but not very good for game design. So here is tic-tac-toe, and I don't think the average person would recognise that as tic-tac-toe. That's quite a verbose description. And when it comes to designing games, we generally want to exercise the degrees of freedom within a rule set. So to try the variants and find the combination of rules that work the best. So if we think that tic-tac-toe is a boring game, we might want to try 5 in a row on a larger board. But making that change to this rule set, we'd have to modify most of the code. It would be quite a process. So there's no encapsulation of the game concepts in this code. And this means it's has very poor evolvability. So if we evolve that code, it would be unlikely to produce a playable game, let alone a good game. And I'd also say that it's not very clear and not a very simple language to use, though it is reasonably general and extensible. It has been extended into variants of GDL to handle a wider range of games. The Ludi GDL is a language I wrote for my PhD thesis. It specialises in combinatorial games, and the aim was to design a language for designing games. So it's high level, highly structured, and very evolvable. And it's based upon ludemes, which are units of game information or game concepts. And as you can see, it's quite a simple language. And most people could probably read that and recognise that for what it is, tic-tac-toe, without any knowledge of the language. And it's very simple to use. If we want to try 5 in a row on a larger board, we just change these parameters. So we can design variants within seconds and new games within minutes. So I'd say this is a very simple language. It's quite clear, and it's very evolvable. This is ideal for genetic programming to create new games. But even though we had 200 Leidens in the language, it proved to be disappointingly limited. It would only handle a very small range of games, and extending it was quite a pain. So what I'm working on now is Ludi with two eyes. This is an extension of the previous approach to a game language. It uses the similar principles to Ludi, but the idea is to greatly increase the generality and greatly increase the extensibility. So it's got a similar structure. We have a control structure describing the players and what type of game it is. We list the equipment and the rules. But again, it's this high-level Leiden-based description of games, so it's easy to manipulate parameters and swap in Leidens to create new variants. And the basis of the new language is a class grammar which generates the game language directly from the source code based on the constructors in the class hierarchy. So this gives the user full access to the functionality of the underlying source code, but hides the implementation details. So the basic syntax is an EBNF style rule set where each class generates a rule where the class name is the left-hand side and the right-hand side consists of its constructors with their parameters, subclasses and terminals, which are the primitive data types and enums. So we start from the root game class and then recursively follow the constructors and their parameters and subclasses to create this grammar from the code base. So say we have this abstract class start, which describes the starting position of the game. We can have two subclasses, one to place pieces on the board, one to store pieces in the user's hand. So when the grammar is created from this code, we would have these three production rules. Since this class is abstract, there are no constructors in this rule, so it follows on to these sub-rules, where we define the constructor and its parameters. So the process for creating the grammar, it's a two-step process. The forward pass goes from the code to create the grammar. Then the games are expressions described in this grammar, and the backwards pass takes these expressions and returns them back to code to compile them into executable games. So there's a direct mapping between the code and the grammar, which makes the program language effectively the game description language, which gives us good generality, and means that any new code that we add to the code base automatically gets substituted into the language. So there are some formatting guidelines when programming the code to produce a clean grammar. Here is the code base, just the top few levels, and here is a subset of the grammar generated from this code base. So the rules are grouped into packages, so they're scoped, and we can have very short rule names. And from these packages, it's easy to find the constructors corresponding to each rule, so we can compile the games as needed. The mechanism for creating optional parameters, there are two mechanisms. We can explicitly annotate each parameter in the code as optional, so this will create an optional parameter. Or implicitly, if we have overloaded constructors in which parameters can be removed unambiguously, the system will also make that an optional parameter in the grammar. And it's also useful to name the parameters. So for this rule, if we just had two ints, that wouldn't be very descriptive. So instead, the grammar keeps the parameter names from the code. So this makes the grammar self-documenting to some degree and much more easy to read and comprehend. On the other hand, there are some functions that we don't need the names for. So again, we can introduce a custom annotation to remove the names for these parameters. And so here we have the rule that's derived from the root game class. And this metadata parameter is the mechanism for incorporating domain-dependent information with each game. So these will typically be help files, credits, metrics, and AI settings, and so on. And so this information is to be used by the calling program as appropriate. The root game class will implement the following functions that the calling program will use to play the game. And I'll probably add a playout function to optimise playouts in future. So it's a very minimal API. The idea is to keep the system as general as possible. And this is separated from the grammar, so the user doesn't have to actually worry about the API. So the class grammar, it makes the language follow from the code. So this allows more freedom to implement the required functionality without having to worry about the grammar. It gives users the full access to functionality, and it hides the underlying implementation details. So the aim is to support a system, is to create a system that will support most games that can be modelled as rules acting on equipment. And this will cover most traditional games and some simple video games, but these are a low priority. So it's currently a work in progress. I expect to have it playing games in a few weeks, and hopefully a stable and useful code base in a few months. And I'd just like to let you know about the Game Design Journal. The third issue is out next week, so please check it out, and we welcome submissions for the next issue. Thank you.
Time for questions, please.
I'm curious, do you intend your code to be usable as a code for a code generator which will take the description of your game and turn it into an app which will run on your mobile phone?
Exactly, I will, yep. Yep. And possibly even the entire system could run on the phone, I think.
But do you have it, or is it something you have on your to-do list?
That's right, yep. It's on the to-do list, yeah.
What sort of code generators do you intend to use there?
I will port the code to Android. The graphics will be an issue. But I think there are ways to do it.
One of your 5 dimensions was clarity.
Mm-hmm.
Is that the same as human readability?
Yes, that's right, yeah. Yeah, it's for, just being able to read a rule set and see what's going on and to make intelligent choices. Yeah.
So the Java code is for extending it, but you can write it in your grammar if you like, or like how does it work with?
It's the other way around.
Oh, okay.
We add functionality in Java, and the language just follows from whatever is in the code base. So the advantage is we can add whatever functionality we want in Java without worrying about the grammar. It just takes care of itself.
Will Ludi 2 include random elements,
Oh,
guys?
yeah.
And
Yep.
so, for instance, Einstein Würfelknecht would not be a problem to realize in Ludi 2?
No, it shouldn't.
Okay. And what would be maximum board size?
How much memory do you have on your device?
Good question. There are borderless games that can extend. There is no maximum at the moment. That's something I'll have to deal with.
So one difference to the game description language in the general gameplay is, or it seems to me, that there's no formal semantics of that language, right?
That's right.
So there's no way to formally prove that the game is correct, or that's what you expected to do, or something like this.
Yeah, there's no specification for the language because it derives from the code. It might be possible to do what you suggest, but that's not a priority for me at the moment.
And another question is because you're writing code, you're writing Java code, that means you can write arbitrary functionality. Is all of the functionality then translated into the grammar, or is some of it just hidden in the code?
Whatever you see in a construct, well, the constructors are what's visible to the user, so there will be a lot of functionality that is hidden to the user.
Okay.
Like the state representation is quite complex, but the user doesn't have to worry about that. They just have to deal with the functionality.
So it's the responsibility of the game designer to make useful constructors so that it's actually
of the
readable.
programmer. Yeah.
Is it good that maybe
It's still being developed. It will be available online, hopefully by the end of the year.
could we participate in your project?
There's an issue of the code that goes into the library that, yeah, I'll probably have to supervise the code in there quite carefully. So I'm not sure about collaborations yet.
But I'm trying to make a 3D game. However, in this 3D game I have multiple puzzle and board game that is 3D. And I was wondering about something like what you...
Okay.
So if I can just use this, if I work it loosely to implement the engine of this game, that I
Yeah, that's what it's intended for, so yeah, that should be possible, yeah.
Okay. Thank you very much.
Thank you.